Hey everyone, today we have these two equations that if x plus y into root x is equals to 3 times root y, this is the equation first, and the second equation is that if x minus y into root y is equals to root x upon 2, this is the second equation. This problem is quite interesting because it contains the linear x and y and also the radical x and y. This makes this problem quite interesting. So let's see how can we solve this problem. So usually when two equations are there, we apply the elimination method, means either add or subtract, but in this case we have to divide this equation 1 and 2. So let's have it. So I will just write dividing equation and 1 all over 2. So a space is needed, so erasing that. Yes, now. So the first step is that divide equation 1 upon equation 2. So now we are dividing equation 1 and 2. This means the LHS upon LHS is equals to RHS upon RHS. So the LHS of the equation 1 is that x plus y into root of x, and the LHS of the second equation is that x minus y into root of y. The second equation and the first equation LHS in division is equals to their IHS in division. So the IHS is that 3 times root y upon root x upon 2. So now here we can see root x upon 2. So this 2 moved at the top as a multiplication, and that 2 multiplied with 3. So 2 into 3, it makes 6 over here. Now after this we will just apply the cross multiplication, means this multiplied over here, this multiplied over here. So when root x multiplied over here and already a root x is present, so root x into root x, it will form a complete x. This is the normal thing we usually see. So x and x plus y in bracket as it is, and that is equals to 6 times, and root y into root y, again it would become a y. So 6 times y and in bracket x minus y as it is. Now opening the bracket, so x square plus xy, and that is equals to 6xy minus 6y square. Now shifting this y square over here and xy over here, this over here and this over here. So 6y square plus the x square, and that is equals to 6xy minus xy, that is equals to 5xy. Now concentrate on this equation which you have obtained over here. Does it seem to be very interesting? Look at it carefully. Yes, now if we have figured out, then it's very good, and if we have not figured out, let's see what makes this equation interesting. So 6y square minus 5xy shifted from over here to here, minus 5xy and plus x square, and that's equals to 0. Now here's a quadratic equation. Yes, it is a quadratic equation if we considered our y as the variable of this equation and x as a constant. So we can obtain over here like 6, this 6 over here, so it would form the a of the quadratic equation, like we have that ax square plus or minus bx plus or minus the constant c, and that's equals to 0. This is the equation, not x we will use, so you will get confused. Let here it be p, means some constant should be there, p and p. So similarly in this case, the highlighting ones are the constant a. Now we have required so b, so 5x is the b that we required, and here you can see nothing is there, means 1 is there. Or else we can see that x square, this is the constant at the last we require, and the variable present in this equation is this blue, that is y square and y. So hence it is a quadratic equation, we can get it over here. So solving this quadratic equation by the quadratic formula, y, that is the constant in this, is equals to negative b. So 5x, it's already negative, so 5x plus and minus under root b square. So 5x the whole square means 25x square minus 4ac. So 4 into x square into 6. So 4 into 6, 24. So minus 24 and x square. So x square. Now we can see 25x square minus 24x square. So it would become single x square, and x square and square and under root cancel. Square and under root cancel. So what remains is only x and upon 2 times a. So 2 times a means 2 times 6, that is 12. What has been used is the quadratic formula, that is negative b plus or minus under root b square minus 4ac upon 2a, and that's equals to x, the variable present in this particular quadratic equation. Now from here we have the two cases, that either y is equals to 5x plus x, that is 6x upon 12, comma the negative one, that is 5x minus x, that is 4x upon 12. Now we can see they are common factors, means 6, 12, 4, 12, so they can be cancelled. So we obtain that y is equals to x all over 2 by the table of 6, comma here by the table of 4, it can be x upon 3. So value of y is this x upon 2 comma x upon 3. Now this can be an important equation over here, so let it be equation 3. The first and second we have already considered. Now the value of y we have obtained in the terms of x. Now if we will put this in any of the equation, we can get the whole equation in only x and we can solve it. But putting over here would be quite difficult because already the radicals are present. So we will form another equation, and that equation is also beautiful. So for that we will use this blue color. So now as we have first divided this both equation, now we will multiply this both equation. So let's see what happens if multiplied. So equation 1 multiplied by equation 2. So if we will multiply this equation, so this multiplied by this LHS into LHS, so x plus y into root x, and that is multiplied by x minus y into root y, and that is equals to the RHS multiplied, that is 3 times root y into root x upon 2. Root y into root x upon 2. Now what are the factors you can see that are cancelling over here? The factors that got cancelled over here is root x, cancel with root x, root y and root y, because all these are in multiplication. This is multiplied with this whole, and that is multiplied by this. 4 factors in multiplication is equals to this. So whatever is present over here, so root x, root y cancel. So what remains over here is x plus y into x minus y, and that is equals to only 3 by 2. Root x, root y has been cancelled. Now a plus b, a minus b, the identity can be seen, so it would become x square minus y square, and that is equals to 3 by 2. Now we have this equation that x square minus y square is equals to 3 by 2. Now the value of y which we obtain, that is root y is equals to x by 2 comma x by 3. These two values of y we will put over here and obtain the value of x, because this whole equation will be in terms of x, so it can be obtained. So the case 1, I will write the case 1, and then we will move for the case 2. So case 1 we will take x by 2, so x square as it is. Now substituting y with x by 2, so x by 2 the whole square, and that is equals to 3 by 2. So x square minus x square by 4, and that is equals to 3 by 2. Now taking the LCM common, so 4x square minus x square upon 4, and that is equals to 3 by 2. So now 4x square minus x square is what? 3x square. 3x square upon 4 is equals to 3 by 2. Now 3 and 3 cancel, so x square is equals to 4 shifted over here and gone from here. So 4 upon 2 means 2, 1, and from the table of 2 it would become 2. So x square is equals to 2, thus our x is equals to plus and minus under root 2. The value of x has been obtained. X can be plus or minus under root 2. This was the case 1. Now let us move to the case 2, putting y is equals to x by 3. So x square minus y square means x upon 3 the whole square, and that is equals to 3 by 2. So 3 square 9, x square minus x square by 9. So taking the LCM, so 9 minus 1, that is equals to 8x square upon 9. So it would become 8x square upon 9, and that is equals to 3 by 2. Now we will shift these constants over here, so it would become that x square is equals to 9 upon 8 into 3 upon 2. 9 and 8 like this way, and 3 upon 2 that was already present. So now we can see x square is equals to 3 into 9 upon 8 into 2, that is 16. Now taking the under root on both sides, as we have done over here, under root on both sides, so square under root cancel, so x is equals to square root of 3 as it is, square root of 9 is equals to 3, and square root of 16 is equals to 4. This is the value of x, and also we will just have the positive only, we will not go for the negative, let it be positive root 2 only. So values of 2x, I mean the two values of x has been obtained, root 2 and 3 root 3 by 4. Now let us put these two values in this to obtain the value of y. So first, as we have obtained the value from case 1, we will put in case 1. So x by 2 is for the case 1. So x we have obtained is that it's root 2. So it would become root 2 by 2. And from case 2 it's x by 3. And for case 2 the value of x is 3 root 3. So 3 under root 3 upon 4 upon 3. This is the value of x, we can see 3 root 3 upon 4 and upon 3 which is present over here. So now 3 and 3 cancel, so what remains is under root 3 by 4. So values of y has been obtained and x has been obtained. So let us have this final table, that what are the two values of x and y compared with each other. So x and y. If x is equals to under root 2, then y was equals to under root 2 upon 2. And if x is equals to under root 3 upon 4, then y is equals to under root 3 upon 3. X is under 3 times under root 3, let it be 3 times under root 3, and y we have obtained was under root 3 upon 4 x, and here we have obtained the y. So here is the final solution, that if x is equals to root 2, y is equals to this, if x is equals to this, y is equals to this. So if you found this problem interesting, do subscribe to the channel and admit that you are unable to solve this problem by giving a like to the video.